Hello, Gen Chem students. I'm going to give you a brief lecture on ICE tables and how to set them up. So this is a question that comes directly from the mock exam. It's looking at decomposition of cyclobutane. You're given the equation of C4H8 gas that's in equilibrium to 2C2H4 gas. You're given the information that at start you have 0.16 mole of C4H8 and it's placed into a 0.500 liter rigid container. You are given a Kc of 9.08 times 10 to the minus 6 at 285 degrees Kelvin. There are no other substances present, and you are asked to find the concentration of the C2H4 at equilibrium. So, you're given only an initial concentration. There's no equilibrium given, but you have your Kc, which means you're going to need to make an ICE table. But before you do that, you're given moles, but you're asked to find a concentration. You're also given the volume of your container, which means that you can find molarity, given that you have the moles of solute per the liters of solution. Just plug in your 0.16 moles per the 0.500 liters, and you can get a 0.32 molarity solution. So here's your ICE table set up. You have your initial, your change, and your equilibrium. So at initial, you have your 0.32 molarities of the C4H8. You know that you don't have any molarity or any concentration of your C2H4. The change is going to be minus x and plus 2x given from your stoichiometry measurements, because you know this equation has to go forward due to the fact that you don't have any reactants. So at equilibrium, you're going to have 0.32 minus x and plus 2x, given the fact that this reaction is going to go forward. Once you have your ICE table set up, you're going to write out your expression. So you know that the Kc is equal to the concentration of the C2H4 squared, due to the fact that it is 2 in your stoichiometry, divided by the concentration of your C4H8. Remember, it's products over reactants. So plug in your numbers and you have the 9.08 times 10 to the minus 6 is equal to the 2x squared divided by 0.32 minus x. Once you get everything equaled out and you distribute your square, then you should get the 9.08 times 10 to the minus 6 equals 4x squared divided by the 0.32 minus x. You can solve using the x is small approximation, and you should get 0.32 times 10 times 9.08 times 10 to the minus 6 is equal to 4x squared. You can then divide by 4, and you get the 2.91 times 10 to the minus 6 divided by 4 equals x squared. Square root the entire thing, so you get the square root of 0.73 times 10 to the minus 6, and you should get x is equal to 8.52 times 10 to the minus 4. And you should always verify your approximation. So you should get 8.52 times 10 to the minus 4 and divide that by your initial concentration of 0.32. Times that by 100 to get a percentage. So you get 0.27%, which is well within a percent error of 0.5%. Using this, you know that you can use that x as a good approximation. So you look back at your setup, and you know that to find the concentration you have to have 2x. So you multiply your x times 2, and that equals 1.70 times 10 to the minus 3. So the concentration of the C2H4 at equilibrium is equal to 1.73 times 10 to the minus 3 molarity. We can take an extension of this. So we know that we can make the X a small approximation, and we verified that it has a small percent error. But we can also solve this using the quadratic formula. And I wanted to just give a warning now that this is just a demonstration, and in no way should you ever do this on any kind of test, as using the quadratic formula is quite time consuming, as you will see. So first off, when you have your formula here at the 9.08 times 10 to the minus 6 is equal to 4x squared over the 0.32 minus x, you have to get that into polynomial format, which is the ax squared minus bx plus c format. So in order to do that, you can multiply both halves by the 0.32 minus x, which is the reciprocal. And once you distribute that out amongst that 9.08 times 10 to the minus 6, you should get 2.9056 times 10 to the minus 6 minus the 9.08 times 10 to the minus 6x is equal to 4x squared. You still have to just subtract the 4x squared, so that way it's all on the same side of your equation, and then rearrange into your correct format, so that you get minus 4x squared minus the 9.08 times 10 to the minus 6x plus the 2.9056x, times 10 to the minus 6, and that's equal to 0. Now you have your correct format, so you can solve using the quadratic formula, which is, as we all know, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you have your format of a x squared minus bx plus c. You plug that in using all your coefficients, and I'm not going to read it out because it is long, and I don't think you want to hear me reading everything out loud. But I will walk you through the steps. Once you're here, and you have everything plugged in, you want to combine and start doing like terms. So you can multiply out and square out your format here. So that way you get your 8.24464 times 10 to the minus 11 plus the 4.64896 times 10 to the minus 5th. Combine these terms so that way you can get the square root. Now remember, whenever you're solving for a square root, you're going to have two roots, the plus and the minus. So once you take your square root of your number, you're going to have a plus and a minus. And once you solve out for this x, you know that you have minus 8.53 times 10 to the minus 4 and positive 8.51 times 10 to the minus 4. Now, a negative answer really doesn't make any sense in this case, because we're looking for a substance that's being formed, and having negative substance really does not make sense. So when we compare to our approximated answer of 8.52 times 10 to the minus 4, we can see that it's very close, which makes sense considering our percent error was very low. And that's how you would solve that using the quadratic formula, which I really don't recommend, but I wanted to show you so that way you would know that really this isn't all just made up, and it does make some math sense. I hope you find this video somewhat informational, and may it help you in any future tests that you have to take.